Okay, well, I think we'll get started here, and all the others that are going to come and join us later on can kind of come along for the ride as they arrive. So for those of you who I've not had the opportunity to meet before, my name is Spencer Snowling. I'm Vice President here at Hydromantis of Business and Product Development. And I have my colleague and old buddy here, Oliver Schraa, who's the president, and he's done quite a lot of the development of CapdetWorks over the past number of years, and he's going to be helping out with the presentation as well. So our plan for today is just a quick introduction to our company, Hydromantis Environmental Software Solutions, if you've not had the chance to learn about us before. We're going to be presenting a bit of a hypothetical case study today that talks about how you can use these two products together to do capacity analysis. We're going to demonstrate that by using both pieces of software today. We'll do a bit of a desktop sharing so that you can see them in action, and wind up with a few final comments and a couple of illustrations about some new and upcoming things that we have planned. We'll also try and leave a few minutes at the end for you to be able to ask us a few questions about either product or any of the work that you've seen today. In this GoToWebinar service that we're using here today, you should see on your dashboard a chat window and a question and answer window. So at any point along the way, if you feel like jotting down a question, please do so. There's the opportunity as well to raise your hand, and we can bring up the audio on your mic so that we can hear you and everybody can hear you. Otherwise, we're going to leave everybody muted just to keep the noise down, and we'll proceed along. So if you haven't had the chance to hear about Hydromantis in the past, we are celebrating this year our 26th anniversary, and we are a company that surrounds ourselves with the development of modeling and simulation-based technologies for wastewater engineering. We were founded by Dr. Gilles Patry out of McMaster University here in Hamilton, Ontario, Canada. And our company has two focuses. One is the production and development of the environmental engineering software that I'm going to introduce over the next few slides, and also to provide services that go along with those products. So as you probably know, GPS-X, our wastewater process simulation and optimization software, is one of our major products, and we have a lot of our business that surrounds that. We released a new version last fall, 6.0, and we'll be releasing a new version, 6.1, this fall. We also are going to be looking today at CapdetWorks, our preliminary design and costing software. We also have a package for modeling industrial wastewater treatment systems called ToxChem. And we have a drinking water treatment modeling package called WATPro. However, today, as I mentioned, we're going to be focusing exclusively on GPS-X and CapdetWorks. So just so that you have a good feeling for the difference between these two different pieces of software, GPS-X is a process modeling package. So it's trying to describe the activity in an activated sludge system and in the clarifiers and solids handling and so on. And it allows you to predict performance. And so we're going to be using that to ask ourselves the question, when does this wastewater treatment plant fail? At what point have we run out of capacity? And alongside that, we're going to be using CapdetWorks. And that is a planning level design tool. And the most important feature that we'll be using today is the ability to do capital costing. And so we are going to be using it to answer the question, how much does this upgrade cost? And so we can use it to cost entire plants or parts of plants, and you'll see how these two things come together today. So to introduce our basic case study today, this is a hypothetical plant, but you could do this on any number of different types of wastewater treatment systems. We are going to work with a conventional activated sludge plant, such as the kind that is shown in this photograph here. And we're going to work with a plant that we feel is, somewhat midway through its design lifespan. So it's something that's been up and running for a while. It's operating well, but it is receiving more flow than it did at one time. And the people who manage this plant are looking ahead to do a capital expansion at some point in the future. And as part of their planning exercise, they want to use modeling tools like what we have available to understand the relevant questions and to look at what their options are. So this plant, hypothetical plant, has been designed for BOD removal and nitrification. And it receives an influent loading here of an average flow of 10 NGD with a peak flow of 15. We're going to try and keep the story straightforward today, assume a temperature of 20 degrees Celsius, and an influent loading as shown over here, TSS of 220, and ammonia coming in of 25 milligrams per liter. So what we're going to do is use our simulation tools to do a sensitivity analysis. And we're going to go through the following steps by using both pieces of software to do this. So the first step in the process is to cost the current version of the wastewater treatment plant as it sits now. So that will be done in CapdetWorks. We start there, figure out what the current value of that plant is. And then we model that same plant in GPS-X and try to predict what the performance is going to be like under different loadings and working at increasing loadings into the future, and determine where that capacity is going to run out, where that plant is going to fail. We will then use GPS-X to evaluate expansion options, the way that they can address how to increase the capacity of that plant. And then at that point, we'll return to CapdetWorks to cost out the option that we are going to choose. So we're going to start with CapdetWorks then for our hypothetical plant. For those of you who have not seen CapdetWorks before, I'm going to just give you a little quick explanation. This is a preliminary design and costing tool for evaluating wastewater treatment plants. It was based on the design algorithms themselves, are based on the U.S. EPA CapDet program from back in the 80s. And it was one of the very first products that Hydromantis ever created back in 1985. Those design algorithms were incorporated into a software tool. It was a DOS-based command line program at that time. And that was one of Hydromantis' first commercial products. So we developed that product and have revised it and updated it a number of times over the year. We've now got a graphical interface on it, and it allows you to design a wastewater treatment plant by specifying a number of individual unit processes. And then it can design the size and depth of those tanks, and then it can do a costing of that as well by using an extensive database of costs for things such as the tank, the concrete, the piping, and energy uses, labor usages, and it gives you a full overall valuation of that plant. So what we're going to be using today is the design override capability. So rather than letting CapdetWorks design a plant for us, we are going to use this design override to enter in the characteristics of an existing wastewater treatment system. So we're going to model the hypothetical plant that we're describing here today. And then we're going to use the unit costing approach to get a cost of, first of all, the plant and then the upgrade after that. So CapdetWorks basically does its costing by taking each of the unit costs for each element and going to this database, as is shown here, and it evaluates the cost for the whole plant. The costing databases that are included in GPS-X have been updated a number of times over the years, and actually we're in the process of updating it for 2011 right now. Each of these costs is indexed so that you can move backwards and forwards through time nicely. And so we use the indexing here, and you can enter in whatever the current values are to bring the associated costs up to the present. Okay, so we have our 5-step process, and we're going to start out with step number 1 by costing our existing treatment plant. So this is the drawing of it here. Again, to keep the story simple and straightforward, we're only going to deal with the parts of the wastewater treatment system that are shown here. So we have an influent wastewater that's coming in, a primary clarifier, a plug flow activated sludge system, and a secondary clarifier. Okay, so I'm going to hop over to my desktop at this point and bring up CapdetWorks. And so as you can see here, we have each of those unit processes that are shown. You'll notice here there's a small symbol with a line through it in the influent wastewater object. The reason that indicates that we're not including that as part of the costing. And the reason for that is that if you do cost the influent, while it adds on a number of other costs such as land costs and other things that are outside of the discussion for today's purposes. So just to let you know that's what that is there. We're going to limit our costing to just the 3 objects on the right-hand side here. So once that's done, I've entered in all of the information here in terms of the sizes and the flows, and I'm going to now perform the costing. So that's done with the click of the button here on evaluating estimating the cost of this current layout, and you get a summary of that detail along this summary line here. So you can get more information if you like by getting our full report, which breaks down the costs for each of those unit processes that were shown on the screen, and some of the detail about the sizes and labor costs and so on. But for the case of simplicity here, we're going to look at the project cost. That is an evaluation of the physical assets of this plant as it stands right now. So for the design of that plant as it sits, we're doing a costing of the clarifiers and the activated sludge system. So we're looking at a current cost of $14,100,000. So I'm going to pop back to my slides here. And I have a table that summarizes this. So the current cost of this plant, $14.1 million, and this project cost is the number that we're going to keep in mind for this exercise today. Now the next step in the process is to analyze the performance of this plant with GPS-X and then project into the future to see how it's going to perform as the loads get larger and larger. So GPS-X, for those of you who may not be familiar with it, is a process simulation tool. And just to give you a quick background about it, it was the first dynamic simulator on the market back in 1992. It allows you to create models of wastewater treatment plants. We have a large suite of models of different types of unit processes. You can run your own simulations of any kind, change any parameters that you like, and analyze those results. We have what we feel are very fast and robust steady state and dynamic simulations. So you can run 100 days in a very short period of time. And we have a large suite of process models that allow you to simulate a large, wide array of different types of plants. It is also an open platform and allows you to customize the models, and there's a lot of flexibility and allows you to do a number of different things and create a number of interesting simulation analyses. So the way it works is that you enter the plant characteristics, you draw your objects on the screen, you enter in the tank sizes, the operational parameters, you specify how much you're wasting, for example. You enter in the loading characteristics, so the influent flow, the TSS, BOD, and so forth and so on, temperature. And then when you run your simulation, it will predict the plant performance. So it will let you know what the concentration is, say, of mixed liquor, how much energy you're using, what the DO is, so on. And what is of importance to us here today is to look at the effluent quality, the suspended solids, the BOD, TKN, and ammonia. So you'll see here when I pop over to my desktop that we build the model in this portion of the screen where you can specify the tanks and arrangements, and you have input that you can play with up here, and you have output on the side. So I won't go into a lot of detail today about the use of GPS-X. We have other webinars where we can go into that in more detail. I'm just going to hop straight to the results at this point. So here's that same plant that I drew before in CapdetWorks, and here it is in GPS-X. So an influent object, a primary clarifier, a plug flow activated sludge unit, a secondary clarifier, and this is representative of the discharge out to a water body with our little happy fish. So when I run the simulation here, I'm just going to run a quick steady state solution. If we look at the effluent quality, so this is the concentrations that are coming out the back end of the plant, we can see that we have a solids of 12 milligrams per liter, effluent BOD of 3.8, and ammonia of less than half a milligram per liter. So this is fully nitrifying, doing a good job on all fronts. So what we're going to do is take a look at the relationship between the effluent quality and influent loading. And I'm going to make use of the GPS-X sensitivity analysis tool here. So I have influent flow on this bar right here. And when I turn on the influent analysis tool, GPS-X is going to run a number of simulations here, one right after another very quickly. And you'll see this value here, the influent flow, increasing and results being plotted on the right-hand side here. So I'm going to quickly run that simulation right now. And so what it did was it basically it ran simulations at a number of different influent flows from 10 up to 25 mgd and plotted the effluent concentrations versus the influent flow. So this gives us a result that indicates to us that obviously as you load more to the plant, the effluent quality decreases. You get higher concentrations with larger loading to the plant. So just to be clear, we're holding all other parameters in the model the same. So we're still, all the concentrations in the influent are the same, even just the amount of flow coming into the plant that we're using for our capacity analysis. Okay, so I'm going to pop back to my slides at this point and highlight some of those results there. So in that sensitivity analysis, we basically started where we were at now, 10 mgd, and we ran simulations, then we increased it, then we ran another simulation and increased it again, and then we looked at where that failure point is going to be. So this is going to depend on what your plant is. So for the purposes of our hypothetical story today, we're going to use these effluent limits, showing here that the TSS effluent limit is 15 milligrams per liter. So if I go to the 15 milligrams per liter on my graph, this is showing me that once the influent flow gets up to about 12 mgd, we're going to be at our limit. And if I look at it from the BOD point of view, we're going to be okay up to about 18. And as far as nitrogen removal goes, well, that was doing well. We are increasing our aeration efficiency. So therefore, we're not going to fail on nitrogen removal, but really we're going to be failing on the solids first. So this plant, this sensitivity analysis that we've done here shows us that we're failing on TSS, effluent TSS first, and really this plant is bounded by its clarifier capacity because we're running out of the ability to keep those solids down as we went to higher loading. So now, the next step in the process is to look at a bunch of proposed upgrades and evaluate them all versus each other. I'm going to, we could spend a whole webinar just on doing that. So I'm going to skip ahead and just basically decide that because we know that we're limited by solids, we are going to build 2 additional secondary clarifiers. So in this particular case, as far as GPS-X is concerned, the way that we implement that is to increase the surface area. So we are going to set up a scenario where we've increased, in this case doubled, the surface area of the clarifiers to go from having 2 clarifiers to 4. So I will do that here. For those familiar with GPS-X, I've created a scenario which has this secondary clarifier upgrade in place. So you still only see 1 object on the screen, but this now represents 4 clarifiers instead of 2 previously. And I'm going to rerun that analysis again. And now we get a different set of results. So we can see that it's essentially the same kind of story here, but we get different lines drawn. And we're seeing that we got a little bit more capacity before we run out. I see somebody's asking a question here. For the sensitivity analysis, was the mixed liquor concentration held constant? So in this particular case, no. We let the mixed liquor vary. We held a constant wastage rate. You could simulate, however, the opposite situation if you like. There's lots of flexibility in modeling that can allow you to set up different types of analyses. So you could allow it to vary, or you could hold it the same. Okay, so I'm going to come back and take a look at those results now. So I'm going to compare those 2 sets of results side by side. So with 2 clarifiers, we can see where we were limited before. And we can see here that by adding 2 more clarifiers, we've achieved more capacity, and these lines are pushed, sort of to the right. That allows us to indicate that we've got more capacity now with our clarifiers, and we get better performance, and we get a little bit more life out of our plant before we fail. So comparing the results side by side here, this is what we had before, where we were limited at about 12 MGD before, when we ran out of clarifier capacity. And now we're good up to just over 16. So we've gained ourselves about 4 MGD according to the model. And this is a nice way to look at doing a capacity analysis. You could possibly say, okay, well, that's what 2 clarifiers are going to give us. What if we increased some, aeration basin tankage? What if we went with different types of clarifiers? What if we had increase in primaries? There's really an endless list of things that you can analyze in this way. But for the purposes of today, we can see that building 2 additional secondary clarifiers is going to give us another 4 MGD, so another number of years for this particular plant. Okay, step 4 in this process now, once that's been completed, is to cost that proposed upgrade. So I'm going to go back to CapdetWorks now and perform the final step in our process. And that is to come here and make the change in CapdetWorks that we've already modeled in GPS-X. So in this case, I'm going to open this menu here for the secondary clarifiers, and I go to my Design Override tab, and I'm shown the size and depth and diameter of these clarifiers. We have 2 clarifiers per battery, and I'm going to increase the number of batteries to 2. So we're now increasing our situation where we had 2 clarifiers. In parallel, we now have 4. So that's the way that I do that, and then now I can recost this, and I get a new number of $15.6 million. I could, if I chose, want to go back in here and take a look at those details. I'll leave that for the moment, and I will return to my slides. And there's a summary of that information out of CapdetWorks, and we can see here that project cost, the value of the physical assets as they would be if we were to build that type of plant with the additional clarifier capacity, has now increased from 14 up to 15.6. And you can see side by side on the next slide here that some of the O&M costs, energy costs, and so forth have also increased as well. But we could look at basically the value of the increase in that plant is now looking at about $1.5 million to build those 2 additional clarifiers, and we can look at the increase in the O&M costs right side by side along with that. So, in conclusion, these 2 modeling tools, when you use them together, can provide you with the ability to first of all, determine the remaining lifespan of an existing treatment system, and to look at evaluating and contrasting potential future upgrade options. We only looked at 1 today, but you could evaluate several of them side by side. Looking at a way to reliably put a cost around those future upgrades. And then once all that's done, it sort of gives you some confidence that you've done your homework, and you can get a feeling, and you can play a little bit of sensitivity analysis around those costs as well to get a feeling for what those numbers are going to be. So I'll mention, I'm sure I've seen now some people have started to ask a few questions, did we do this or did we do that? Today's example, we acknowledge, is very simple. I had to make a number of assumptions just for the purposes of making the story fairly simple and be able to tell it in 20 minutes. But there are certainly a potential to do a lot with this particular approach. You can use this type of approach, but with different models to study expanding your primary clarifiers. Of particular interest would be doing aeration capacity. I kind of wanted to do that as our demonstration today, but it's a little bit more detail and a little bit more complex story, but of course that much more valuable. Solids handling, digestion, is your system going to run out of solids handling capacity before it runs out of treatment capacity? Influent concentration changes. If you were in a position where maybe the hydraulic loading, maybe not the flow is your problem, but a sudden change in influent concentration, either up or down, if that's a particular problem for you, you can do these types of sensitivity analysis and scenario analysis along with CapdetWorks to put a dollar sign on it, and that can give you a lot of interesting information. Okay, so I would like to just highlight a few things. I see that people have asked a few questions, so I'm just going to highlight a few things coming at Hydromantis, and we'll put some time to questions at the end. Just mention that we have released a new version of our ToxChem software for modeling the fate of VOCs, pharmaceuticals and personal care products, endocrine disrupting compounds, and so on. Any types of microconstituents you can model with ToxChem. That's now available, version 4.0. We have released and expanded our video library on our website. If you click on the Videos tab, you can now get all of our tutorials for GPS-X and ToxChem and CapdetWorks now, so that you can learn how to use our software and learn about all the detailed features. I think we're up to about almost 3 hours worth of video on our website. We're continuing to offer training for all of our packages. We offer the training where we can come and visit you, or you can come and visit us, or we offer it online just like we're doing today. I'll note that our next webcast, using GPS-X to design and optimize upflow anaerobic sludge blankets, is on Tuesday, September 22nd, and it's now available. If you click on the Webinars tab on our website, you can register there. So if you want to hop over to hydromantis.com, and you can register under the Webinars tab. And lastly, I'll mention that we're going to, as always, be at WEFTEC in Los Angeles this October. And we will be at booth 2859. And I'll highlight it on the map here. We're way over in the corner near the bathrooms, but please take time to come over and visit us at the booth. We'll be highlighting GPS-X version 6.1 and other software as well. Lastly, I'll mention that we are offering our services as well, modeling and building and calibration services. We can help you design sampling programs for the calibration of your models. And we can perform this type of consulting analysis for you using our software tools. So if this type of analysis is of interest to you, please contact us and we can help you out.